Hi YouTube and welcome to my channel. My name is Patrick. If you're running Linux, you probably think that you're pretty safe. And I will say you're probably safer than someone running Windows. But the thing is, you're probably not as safe as you think. Is the Linux security model all security through obscurity? Or are there real layers in there to defend you? Well, today we're going to dissect that question, and we're going to figure out, is Linux really secure? So it's a widely held belief that Linux is inherently secure, and I want to dispel that rumor. Nothing is inherently secure, and we'll talk more in detail about that in just a second. But people also say that open source means that things are going to be more secure by default, and much of Linux is open source. So is that not true? Well, maybe it's true, maybe it's not, because there's other people who say that Linux is insecure because it's open source, so people can find vulnerabilities easier. And so these two things can't coexist. One of them has to be wrong. And the truth of the matter is, if you crunch the numbers and you look at the total number of vulnerabilities that Windows has, and compare that to the total number of vulnerabilities that something like Fedora Linux has had, and you compare those numbers, you'll see that Windows has slightly more vulnerabilities found every year, but Fedora Linux has slightly more severe vulnerabilities found every year. The average severity is higher. In both circumstances, the time to fix was pretty quick, so there's not really a difference there between closed and open source, at least in these competitors. But my point with all of those numbers is that open source and closed source end up being just about as secure as one another at the end of the day. This isn't an opinion that I've formed, this is factual based on the numbers that I've crunched. So yeah, on Linux, I would dare to say that most Linux users are not as secure as they think they are. And the number one reason for that is that the user is the vulnerability. So hear me out. On a Linux system, every Linux system comes with a backdoor built in that gives you total control, and that is the keyboard and the mouse. Look, I mean, the ability to type commands on a system and manipulate its input devices, whether it be local or remote, is ripe for exploitation. You see, the attackers, they often take the same paths that legitimate users take, and that's on purpose. It's the path of least resistance. So as long as there's a way to legitimately use a computer system, there's going to be a way to abuse it. Things that come with your system, like SSH and other remote access tools, they're built so that an administrator can remotely administrate the system. However, attackers will use those same tools to attack the system. And here's the thing. Let's say you're a sysadmin at a company and you encrypt the home folder on a Linux server for security, and then you take the key and hide it. Now, let's say an attacker encrypts the home folder on a Linux server and takes the key and hides it. Well, that's malicious, and that was malware. The software that was used there was malicious, so it was malware. But the thing is, the same tools were used both times, and the same tools were used the same way both times. So from the computer's perspective, how can it tell the difference between a sysadmin doing a legitimate action and an attacker attacking a system? Because those two things often look identical to the computer. And so you can have your antivirus, and it'll catch 80% of the garden variety stuff. But if you get someone whose hands on the keyboard trying to get into your system, there's a good chance that they'll be successful. So here's a question for you Arch Linux users. Did you install and set up SE Linux? Did you install and set up SE Linux? I didn't think so. So that's a big problem, especially because Arch has access to the AUR, which we're going to touch on in just a moment. But yeah, you probably didn't set up SE Linux on Arch. Uh-oh. That's a problem. SE Linux and AppArmor are alternatives to one another, but they're pretty mandatory on Linux systems. They're called mandatory access control systems after all. but you definitely need one to stay safe. It's not an antivirus. It's not going to do the same thing as an antivirus, but trust me, it's useful. If you want to learn more about it, I'll put links in the description. And the second reason I have why Linux isn't as secure as you think is upstream vulnerabilities and weaknesses. So when you have a Linux system and you get updates to your software, those updates have to come from somewhere, and they come from the repositories, a collection of software available for download. So that's all fine and dandy, but who runs the repository? Okay, so it's someone who's vetted by the community and they've been doing it for years, fine. But they're the weakness here, because if they get compromised, then maybe someone can sneak something malicious into the repo, and all of a sudden you're downloading an update, and guess what? In order to install updates on your computer, the process that's doing the updates has to be ran as root. So now you have a situation where code is coming into your computer from the repository and it's being saved and ran as root. Basically, my point here is that the distribution repo maintainers have root access to your computer. The people who maintain the repos that you get your software and updates from, they have root access to your computer, and that is becoming more and more of an issue. Because look, for example, at the XZ backdoor that came out like 6 months ago, a year ago, I don't know. Anyway, a Linux developer was compromised by a very sophisticated social engineering attack, and they almost got malware to be included with every Linux distribution. They were that close. And then some Microsoft engineer with too much time on his hands got macro efficient with his processor, and all of a sudden he finds this backdoor just by chance. I mean, yeah, we stopped it that one time, and that's good. But now that it's an established thing that people can do, we're going to see a whole lot more of that. So your package maintainers, the repo maintainers, they are a threat to your system. Also, speaking of which, the AUR, FlatHub, even the Snap Store, these are some of the main places where people get their Linux applications, and all of them have had issues with malware. All of them have hosted malware on their systems that you could download and run on your computer. So even the source of software that you're probably using isn't even that secure, because for a lot of these app stores, anyone can upload anything. They're not moderated like the repos are. So yeah, with all of that information, you probably feel a little bit unsettled. And I'm sorry, that wasn't my intention. I'm going to leave you with some advice. You are going to have to accept some risk. In order to operate in the world, you have to accept risk. When it comes to using your computers, you'll have to accept risk. That's just what we have to give up in exchange for getting things done. The thing is, you want to be deliberate about what risk you take. The way you can do this is to set up a threat model. So sit down, write down everything that you want to protect, and then write down everything that could put that in harm's way, and then mitigate against those threats. That's a really basic idea of threat modeling. It's quite different than that, but for your first threat model, that works just fine. So write down what you realistically need to protect yourself from, and then put measures in place to protect things in alignment with what you're trying to do. And, that can consist of things like debloating your system, getting rid of stuff that you don't need in it. It could involve setting up multi-factor authentication to log into your system, encrypting your disk. All of this kind of stuff that's optional that you're expected to do on your own, you should do on your own. But write down a threat model, right? And just get a rough idea of what you're trying to protect and from who you're trying to protect it. And that will guide you in deciding what you need to secure, when, why, and how. Anyway, thank you for watching. My name is Patrick. I don't salute. I've never saluted at the end of a video before. I never really know how to end these things. All right.